Okay, see question number 18. Let function f, g mapping R to R, both are real numbers, be defined as f of x is equal to modulus of x minus 1 and g of x, see when x is greater than or equal to 0 e power x, less than or equal to 0 x plus 1. See here equal to both sides they have given. Observe carefully. If x is 0, e power 0 is 1. If x is 0, here 0 plus 1, 1. That means both areas 1 is going to come. That is why this function is valid, not a problem. Then the function you see f of g of x, that means f of g. Whether 1 1 are onto or not 1 1 not onto, both 1 1 and onto are onto but not 1 1, like that they are asking. See how to solve this question and all. See f of g. So let me write first f and g. See your f of x will be modulus of x minus 1 and g of x will be e power x when x is greater than or equal to 0, x plus 1 when x is less than or equal to 0. Then see what I want to say. F of g of x is equal to, see this is f of g of x. In place of x you have to put g of x. That means first write modulus in place of x g of x. That means e power x. I will write here. Okay. Let me write. See f of g of x is equal to, see e power x minus 1 but modulus. Because g of x is e power x. In place of e x you have to keep e power x minus 1 modulus, where this e power x is greater than or equal to 0. Okay, this I need not keep. Again x plus 1, that means see x plus 1 minus 1, but this should be inside modulus where this x is greater than less than or equal to 0. Is this correct? Yes. Now rather than f of g of x I will write f of g. F of g is equal to, see e power x minus 1 you keep like this only modulus where x is greater than or equal to 0. Now you see plus 1 minus 1 if you cancel out modulus x when x is less than or equal to 0. Okay. Now you tell me when x is greater than 0, is this function is going to come anytime negative? No. Why? Because e power x is always greater than 0. E power x is always greater than 0. Always greater than 0. It is not even equal to 0. Okay. Then greater than 0 it is going to become, and you are going to give 0 or above. Even if you give 0 also, e power 0 is 1, 1 minus 1 is 0. Okay. That means you shall write like this. Now f of g e power x minus 1 when x is greater than or equal to 0. Why? Because I need not keep modulus. Anyway, it is going to become positive function. Okay. Another thing. See, what is this function? This function we know very well. When x is less than or equal to 0, modulus of x is going to become minus x. Okay. When x is less than 0, then modulus of x is going to become negative x. Okay, now let us plot this graph. Okay, see I am plotting this graph. First of all, this function I am plotting, or else negative function I am plotting. See negative function, how we know? If x you are going to give 0 or lesser, that means input x is going to give 0 or lesser, negative x is going to come. That means x we are giving and negative x is coming, going to become y positive. Definitely. That means what I want to say, y is equal to minus x, but you are giving negative only, minus x, minus of minus x, going to become positive x. Okay, this side. This is the graph of y is equal to minus x. Now go for e power x minus 1. See, without this minus 1, e power x graph we know. This is the value. At 0 x, this is going to become 1. When x is 0, y is 1. Now Here when x is 0, y is 0. That means this is going to start from here. This is going to become y is equal to e power x minus 1. When x is 0, y is 0. X is 0, e power 0 is 1, 1 minus 1 is 0, y is also 0. Okay, now you tell me, is this 1, 1? No, why? Because if at x is some 2, some value will come, at y is also minus 2, and x is plus 2 also some value is going to come. That means see, both values are going to come. This is not 1, 1, this is many 1. Okay? 1, 1 you cancel out, 1, 1 you cancel out. Okay? Not 1, 1, okay, but onto, whether is it onto? No, why? Because see here you are giving negative input, positive input, but only positive output is going to come. Negative output is not going to come, but we are giving R to R. All numbers are there, positive, negative, all. That is why this is not onto also. Neither 1, 1 nor onto. This is correct answer. Now we will close this class. We will continue in the next class. Thank you very much.